Simplifying trig expressions. Before we can start verifying trig identities, we have to know how to simplify, which we really know how to do already, but we're going to do a few examples just to remind us what we're going to be looking for as we try to verify some of our identities. First thing you might do is you might multiply and then simplify as much as possible. So if you look at the first example, tangent of theta plus 1 squared. Of course, we know that means I have to write the tangent of theta plus 1 times the tangent of theta plus 1 again. That's what squared means. I'm going to multiply it times itself. So now I have to do FOIL, tangent of theta times tangent of theta, which will be tangent squared of theta. And then inside I'm going to get tangent of theta and then another tangent of theta. So I'm going to have plus 2 tangent of theta. And then I'm going to have 1 plus 1 times 1, which is going to be plus 1. Now don't we have an identity that we can replace with tangent and 1? Well, if you remember, we had sine squared of theta plus cosine squared of theta equals 1. And then if I wanted to get tangent squared, I would have to divide this by cosine squared. But of course, if I do it to one thing, then I got to do it to everything. So this would give me my tangent squared of theta plus 1 equals secant squared of theta. So to simplify this expression, I'm going to put these two together. So I'm going to put tangent squared of theta plus 1, and then after that plus 2 tangent of theta. So this part, tangent squared of theta plus 1, can be replaced with secant squared of theta plus 2 tangent of theta. Now sometimes simplifying it is going to help you be able to do something else, and sometimes it won't. But you have to multiply it out and then see what you've got after you've multiplied it out and see if you can combine any things together to get the answer. And again, you're not looking for a specific answer. When we get to proofs, we're going to look at how we can simplify something in order to make it the same as something else. Okay, let's look at the next one. Secant of theta plus tangent of theta times secant of theta minus tangent of theta. Well, of course, we're going to multiply the first two things together again, and we're going to get secant squared of theta, and then tangent secant, and then negative tangent of secant. So those will cancel each other out. And then tangent of theta minus tangent theta. When I multiply those together, I get negative tangent squared of theta. And remember, a minute ago we just wrote down that tangent squared of theta plus 1 came out to be secant squared of theta. So I could replace this secant squared right here with this expression, tangent squared plus 1. And you might be asking, well, why would you want to do that? Well, the reason I want to do that is because you'll notice that once I write it down, now my tangent squared of theta is going to cancel out, and I'm left with just a simple 1. So you have to think about what you could rewrite it as. Could I rewrite tangent as anything? I could have rewritten it as secant squared of theta minus 1. And I would have still ended up with the same answer. So there's multiple ways that you can do it. But one thing you want to try and do is whenever you have a binomial and another binomial, you want to multiply them together. Another thing you have to do when simplifying is that you have to factor. Remember our different patterns that we did? Still going to be the same thing. Sine squared of theta minus cosine squared of theta, that's a difference of squares. So I'm going to write down my binomial times my binomial, and I'm going to get sine of theta plus cosine theta and sine theta minus cosine theta. So sometimes you're going to have to factor, sometimes you're going to have to multiply it out, but your goal when you're doing a trig proof is to make it equal to something else. And so right now in this unit we're just focusing on how can we simplify it. Can we factor? can we multiply it? What's going to help us to, so that we'll be ready when we start our proofs. So this one, notice we have a cosine squared of theta minus 2 cosine theta plus 1. This is again a trinomial, so we're going to do binomial times binomial. And if I want to get cosine squared, I know I have to have cosine theta here and cosine theta here. And then I have to have 1 here and 1 here to make the positive 1. But to make the negative 2 here in the middle, I'm going to have to make these both negative. This one, remember our first step of factoring is to see if there's something in common. And this one has something in common. There's a tangent of theta in front. So I'm going to be left with 1 plus sine of theta. Now notice that this is 1 plus sine of theta. Can I replace that with anything? No, because remember that our identity that we learned was sine squared theta plus cosine squared theta equals 1. We don't have one that has just 1 plus sine theta. So we're actually done at that point. In our last example, if we had 1 minus sine to the 4th, still this is going to be a difference of squares. To get 1, I'm going to have 1 and 1. To get sine to the 4th, I'm going to do sine squared of theta and sine squared of theta. And then 1's going to be minus and 1's going to be plus. And if I go back to that one that I had, sine squared theta plus cosine squared theta equals 1. Well, what if I move the sine squared theta to the other side? Then I would end up with cosine squared theta equals 1 minus sine squared theta. So I could change this to cosine squared theta times 1 plus sine squared theta. And again, when you're doing these, you're going to be trying to see what you can do with it, because there's really nothing else I can do with 1 plus sine squared of theta. Now maybe this is done, maybe it's what I'm trying to make it look like. So right now we're just looking at different ways that we can rewrite it, because that's what you're going to have to do in this section. So you're going to have to be able to rewrite it so that you can make it match whatever it is that you're trying to match in order to prove the identity you're trying to prove.